So we're all here today because we all believe that an agent is not an agent if it can't take action. And that's why we use sandboxes. That's why we use MCP servers. That's why you use orchestration systems like LangGraph and Mastra. But we all want agents to not only take actions, we want them to take actions that matter. So I'm Alex. I'm the co-founder CEO of Arcade.dev, and we're an MCP runtime. We make it very easy to connect your agent to hundreds of high-quality MCP servers and control and trust what they're doing. So we answer three basic questions. The first one is, can this agent, on behalf of this user, perform this action on this resource? Can Claude, on behalf of Alex, send an email on Gmail? That's called authorization. The second question we ask is, what MCP servers can my agent have? What tools can it have access to? Are they any good? Can it pick the right tool in the right moment? Can it pick the right parameters for that tool based on the context the agent's going to have in the moment so that we do the right thing? And the third question is, if we're connecting it to all these important systems like email, infrastructure, CRM, ERP, whatever you want, how do we create rules and policy for what the agent can and can't do so that we can trust the agent? And that's called governance. So we are going to show you a cool agent. We're going to build a triage agent. We all want agents to do work for us, and nobody likes handling tickets. So, you know, a bug complaint's going to come in via email. The agent's going to pick it up. This is a background agent. It's going to spin up a Daytona sandbox. In that sandbox, it's going to pull down the Git repo on the fly. It's then going to go do its investigation and fix workflow. It's going to fix the bug. It's going to issue a pull request. It's going to update the linear ticket for this bug. And then it's going to clean up the rest of its process by sending a Slack message to the engineering channel, by creating a report in Google Docs of what it did and what the root cause was. And then it's going to clean up the Daytona sandbox. But what's important here is that all of these services are important systems. These things are all controlled by authentication and authorization. Many of these require a human to have an identity so everything can be traced back to a particular person. So it's not just the agent running on its own permissions, it's the combination of the agent and me. What's also important here is that we are going to have custom policy. So pretend in this organization, we have rules around how sandboxes get created. We want to make sure that it's got the right resources because we don't want to waste a bunch of cycles. And we want to have some sort of human approval to make sure that the agent isn't going haywire. So that's a demo we're going to show you. So let's cut back over here. And first, let me show you Claude code, which is going to be the agent we're using because we didn't have time to build a custom agent. And we are going to show you first Arcade. This is Arcade. Think of us like an API gateway or an MCP gateway. And what we've done is, even though we've got hundreds and thousands of tools, we've set up just a few dozen for this agent. We've got all the Daytona tools. We've also attached some GitHub tools, some Gmail tools, some Google Docs tools, and some linear tools. Everything this agent needs to do its job. Now, and then over here is our agent. And we are going to clear it out from our demo earlier. And we're going to run it again. Now, cool. So the agent is now waiting for a bug. So we're going to go over here, and we are going to send an email. And we're going to wait. going to take a few seconds while that email goes, hits the inbox, and the agent picks it up. Any second. Live demos, fingers crossed. OK, there it goes. So it picked it up. It's now launching Claude Code with skills of what to do. Claude Code is off and running. Now, we put an artificial break in here. You can imagine this is a background agent. It would be fully autonomous. We would normally run this in YOLO mode. But for us to have an ability to even talk about it, we inserted an approval. So what we're about to do is we're about to create a sandbox. And so if you think of how Arcade works, the agent is going to pick the tool, pick the parameters, send the request out to us via MCP. We receive it, and we're going to route it to the Daytona MCP server that we're hosting and running. Right before we execute that tool, we're going to break out into what we call a contextual access request. We're going to go break out to this other system. It's a custom system. You can, in your organization, it can be your Active Directory system, it can be your Windows mail groups, it can be some random code you wrote. In our case, it's just a little bit of YAML that's going to tell us what the policy is. We're going to go check that right after we make the tool request. Now, it's going to fail because it's going to require human approval. And so that's going to kick off a request for someone off screen to go approve our ability to spin up the sandbox. So let's do that now. So it failed because it does not have approval yet, and it's going to try again in a few minutes or a few seconds. It's going to try again. We're going to take a beat. Let's try it again. Still doesn't have access. Still waiting. Let's try one more time. It's been approved. Now it's going to continue its flow. And it tries to create a ticket, but it can't. I haven't authorized it yet to create a ticket. So we're going to go through the authorization flow in linear. We're logged in now. It now has approval. It's going to try again. As it's going through this, every single request that it is going through authorization checks. Many of these services have already been pre-authenticated and pre-authorized, so you're not seeing an authentication and authorization flow. But some of them, like linear, have intentionally not been authenticated or authorized, so that we can show what an authorization flow looks like. It's finding the issue, it's creating the branch. But now here, it needs to update the ticket again. This is a show of what we call least privileged access. We authorized it to create a ticket. But to update a ticket, to edit a ticket, is actually a higher level of authorization. So it needs to authorize with us again. So we're going to give it that access, and it's going to proceed. And the important thing here is there are two different kinds of authentication and authorization happening. Some of these, the agent is authenticating as itself, as a service account. But for many, it's authenticating and authorizing using what's called delegated user authorization, which is a fancy way of saying OAuth. You know the screens you click on a million times every day to give something access to your accounts? That's how teams and organizations want an agent to access something. It wants to make sure that not only does the agent have access, but the user that's driving it also has access to avoid what's called a bypass vulnerability. So everything's worked out. We have found our fix. We've created our tickets. We've updated our tickets. Now we're going to issue the pull request. Artificial break to give us the time to talk about it. We're going to say yes. Now it's updating the linear tickets to close them out. And now it's doing cleanup work. It's deleting the sandbox to making sure that everything's been spun down so you're not being charged. And now it's going to update more linear. Again, an escalation of privileges, we're going to give it access. And as part of its closeout process, it's hitting Slack to send a message to the engineering team, and it's creating a report in Google Docs. And we're going to show you that while it's running. So there is the bug report in Slack. And we'll wait. And here, well, as you can imagine, we've run this a lot, so there's a lot of tickets now in linear. Let's reload this. There is our pull request in GitHub. And when we go back to this is the final assessment of all the work that it has done. It has created a linear ticket. It managed the sandboxes. It configured the Git identity so that the pull request was attached to me as the user. It found the bug, it applied the fix, created the branch, pushed it, issued a pull request, then cleaned everything up and sent the reports to everybody. And then here we can see the Google Doc triage report, all completed. So if we go back to our story, what's important here is for all of the visions we have for agents, that they can do all this work on our behalf, almost all the systems that we want them to interact with are systems that matter. And because of that, we need to make sure, and organizations want to ensure, that everything's properly authorized, that the tool calls are accurate, and that everything is traced and controlled with reasonable guardrails. And that's what Arcade is. We're an MCP runtime. We help developers fire and forget on authorization for tool calls, tool reliability with high-quality tools that are tested and eval'd for agent selection and prediction, and allow you to apply the governance that you or your customers are going to require when this starts to access systems that matter. Thank you for your time.